The next type of polynomial which we're going to discuss in the session is trinomial. Monomial, a polynomial of one term. Binomial, a polynomial of two terms. Trinomial, a polynomial of three terms. It's as simple as it is written out here. Trinomial. Tri refers to three, and hence trinomial is a polynomial of three terms. This is how we understand the definition of a polynomial. For example, if I have p of x let's see if this is a trinomial or a monomial or a binomial. So in order to do an example problem of this sort in identifying for the type of a polynomial, we first try to simplify. As the condition says, the polynomial has to be in the most simplified form before we justify for that polynomial being of the three types. So let's try to simplify this polynomial before we justify on the trinomial case. So we need to first expand this, as we know that in the lower classes what we have learnt, we expand first 5 with this, and then we expand x with this. So each of the term of the first bracket is multiplied with the terms of the second bracket. That is how we understand the multiplication of two factors or two expressions. Now, as we multiply first 5 with this and x with this, then on further multiplication of 5 to each of the terms, 5 times this and this and this, and each of this multiplied to this, we come across 5 times 3 first, which is 15, then 5 times of x for the second term being 5x, and then 5 times of x square, which is 5x square, then x times of 3, which is 3x, and x times of x, which is x square, and x times of x square, which is x cube, is how we understand the multiplication of each of the terms when expanded through the brackets. Let's try to further simplify this. As we see that this can be more further simplified by taking the constant here and then by pairing all the terms x one side together, and then I get this to be 5x plus 3x, which is 8x, is how we understand, and then minus 5x squared plus x squared, which is minus 4x squared, and then I get this to be minus x cubed. That's it. And I cannot further simplify this. This is the end of the polynomial. Now clearly I see that this polynomial, let's see if this is a polynomial. The power of x here is 0, and the power of x here is 1, and the power of x, the variable x, is 2, and the power of the variable x here is 3. Therefore, each of 0, 1, 2, 3 belong to the whole numbers, and therefore this is a polynomial. This polynomial has 4 terms, but a polynomial of 3 terms is a trinomial. Therefore, this cannot be a trinomial. The given example problem is not a trinomial. For a trinomial, the most simplified form must be of 3 terms. So here we conclude saying that this is not a trinomial. Is how we understand the concept of trinomial and not a trinomial. Let's take one more example to see if that is a trinomial. For example, I have this to be f of x equals 5 plus x minus 4x squared. Yes, in this case, the power is 0, the power is 1, the power is 2, and therefore all 3 belong to W, and hence because it has 3 terms, the first term being 5 and the second term is x and the third term is minus 4 times x raised to power 2. Therefore, it has 3 terms. and since it has 3 terms, it's a trinomial, a polynomial of 3 terms. Therefore, f of x is a trinomial. It's a trinomial is how we conclude. Binomial, trinomial, and monomial is what we discussed as the different types of polynomials. Now let's take an exceptional problem and identify if that is a trinomial or a binomial or a monomial. For example, I have f is from x to x square minus 3x plus 5x power minus 2. So let's see what kind of a polynomial or whether it's a polynomial or not. Now clearly I see that there are 3 terms, but I can call this to be a trinomial, but no, this is not a trinomial, because for a trinomial initially it needs to be a polynomial. So for the first term I see my power is 2, and for second time my power of the variable is 1, and for this my power of the variable is minus 2. 2 and 1 belong to whole number, but minus 2 is not a whole number. Since minus 2 does not belong to W, therefore it fails to be satisfying the definition or the rules to be defined for a polynomial. And therefore, with this rule breaking up, I say that the given function, therefore f from x to x square minus 3x plus 5x is not a polynomial, and hence is not a trinomial. Therefore, the condition for the given expression to be a type of a polynomial is that it needs to be a polynomial itself initially. So this is not a polynomial and hence not a trinomial, is how we conclude the given example problem. Next, let's discuss about the types of polynomials which are in 1 variable and 2 variable. That is, we're going to discuss about 1 variable polynomial and 2 variable polynomial or a 3 variable polynomial. In order to discuss that, let's classify the types of polynomials into 3 types. The first one is 1 variable polynomial. The second is 2 variable polynomial, and the third is 3 variable polynomial. So let's see each of the classifications of the types of polynomials: 1 variable, 2 variable, and 3 variable. So in this, as we have discussed, if the polynomial has only 1 variable, say for example, I have p of x is equal to 5 minus 3x plus 4x square, then in this case the variable is only 1 variable. Therefore, such a polynomial which has only 1 variable x is called a 1 variable polynomial. What is a 2 variable polynomial? It concludes in the same manner as we have defined for 1 variable polynomial. That is, if I have 2 variable polynomial generally denoted by p of x comma y, then we clearly identify that there are 2 variables x and y in case of the polynomial px comma y. For example, if I take a polynomial of the form pxy is equal to x square plus xy plus y square, then this is a trinomial of 2 variables or a polynomial of 2 variables x and y. Here the variables being x comma y on the right hand side expression. So this comes to be a 2 variable polynomial. Next, let's see a 3 variable polynomial followed by the 2 definitions coming from 1 variable to 2 variable and then 3 variable. It is quite obvious that a 3 variable polynomial would be defined as px, y, and z. The 3 variables identified here are x, y, and z. And for example, if I take a polynomial to be 3 minus 5x plus 4yz plus 2x square z cube, then I say this is an example of a 3-variable polynomial because it has 3 variables x, y and z. And interestingly, all these 3 are polynomials because they satisfy with the condition that the power of x here is 0 and the power of x here is 1 and the power of x is 2, which belong to whole number. And coming to the second example, the power of x is 2, the power of x is 1 and y also is 1 and the power of y is 2. So each of the powers of x and y taken independently are nothing but whole numbers, and hence the whole expression here is a polynomial of 2 variables x and y. Let's see the third polynomial of 3 variables. The power of 3 is 0, the power of x is 1, the power of y is 1 and the power of z is 1 and power of x is 2 and z is 3. As we see, independently 0, 1, 1, 1, 2, 3, all the numbers belong to whole numbers. They all belong to W, and therefore this whole expression is a polynomial of 3 variables x, y and z. 2 variable, 1 variable and 3 variable polynomials, the types of polynomials in the branch of mathematics.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.